medians is the last big one we're going to do. We're going to have to do orthocenter as well, but I mostly just need you to identify that. We're not going to do a lot with it because it's less useful. All right, so the medians and the centroid. The median is a segment joining a vertex to the midpoint of the opposite side. Okay, so on that graph right there, or on that picture, this right here is your median. It does split these sides in half, but it is not perpendicular like we saw before. It goes from the vertex to the opposite side. And the three medians of a triangle intersect at a point called the centroid. And if I'm remembering correctly, the centroid is important because it's like your center of mass for your triangle. So like if you had this triangle and wanted to like balance it on the tip of a pencil, then you would need to put that pencil right there at the centroid and it should be able to balance for that. So it's like your center of mass for that. So if we look at this picture, we have to list the medians. Remember, medians go from a vertex to the midpoint of the opposite side. Who can tell me one of the medians on this picture? FB, yes? Okay, so that would be from here, the midpoint, over to the opposite corner, the opposite vertex there. That's good. AE, very good. That's another one. And CD is the last one. Those are our medians. Very good. Okay, so our centroid in this case is point P. I'm not sure why there are 4 blanks here, because I only have 3 things to put in these blanks. So maybe I'm missing something, I'm not sure. There is a special property that exists for the medians. So that centroid right there is going to cut your median into pieces where BP is twice as long as FP. So like, for example, it might be a little easier to see with numbers. If BP was 10, then PF would have to be 5. Right? So BP is twice as long as FP. That is also true for your other medians. The long part, so if we're looking at like AE right here, the long part, AP, has to be twice as long as PE. And for CD, the long part, CP, has to be twice as long as DP. There. And like I said, I'm not really sure what they want on that fourth blank right there. I don't know any other properties, so these are really nice notes. I like them very much, but I don't have like an editable copy of them. I got them from Miss Martin. Miss Martin got them from somewhere else. Not sure. Okay. Questions? Okay. Let's add this to our note card. So get your note card. All right, this one's pretty easy, Jeremy. It should be pretty easy to draw. Okay. All right, so I'm going to do the back of mine where I'm going to have the segment. You might still have room on the front, but we just have two more, so, and the center. Okay, so the segment that we want to draw, we're just going to draw ourselves a triangle. Okay, and if we're just drawing a single median right here, I'm going to just find the midpoint of a side. It doesn't matter which side. I think I'll do this one. So if that is my midpoint, that means that these two pieces right here are the same. So draw yourself a triangle. Put you a dot in the middle of one of those sides and mark those two pieces equal to each other. All good there? Okay, now just go from the vertex right here. You're going from the vertex down to that midpoint. So you're just drawing a line from the vertex down to the midpoint. You can use your other note card as like a line right there, and then I'm going to highlight it because that's the one we're looking for. That is our median. It depends on what your original triangle looks like. Yours probably is not very slanted there. So that is a median. They do look similar. I agree. But we know this is a median because it goes from the vertex to the midpoint. Okay? So for our center, we're going to draw a similar triangle to what we just drew. And you need to find the midpoint of each side. So put yourself a dot right there in the middle of each side of that triangle. And I would go ahead and mark it. So this piece is equal to this piece. This piece is equal to this piece. And this piece is equal to this piece. Now for median, our lines go from that midpoint where? Up to the opposite vertex, right? The opposite corner there. So we go from here to here. Here, we got to go to the opposite vertex. So we're drawing that line there. And then for this last one, we're going from this midpoint over to that opposite vertex there. And if we did it right, they should all meet at a single point right here. I'm pretty close. Mine's a little bit off. Okay, so this point right here is my centroid. Now, I think the easiest way to show that property where like the medians are cut into the long piece being twice the short piece, is just to put some actual numbers on here. Of course, these numbers are not always the same, but let's say that this piece right here was 6. If this piece right here is 6, what would the length of this piece right here be?
12.
It'll be 12. And that would be the case for all the other pieces. I'm not even going to fill those in. I think we just need to see that one to show us the short piece is half of the big piece, right? Or the big piece is twice the short piece, whichever way you want to say it. Okay? Are any of these perpendicular? No. They could be for a specific triangle, because like we take and drag our corners, you could end up with them being perpendicular, but the vast majority of the time they are not perpendicular. So notice on that centroid, you don't have anything drawn that's perpendicular. So when you're trying to pick that out, that may help you some for that. So let's look at doing some problems with these. Actually, let's make sure everybody check your neighbor's note card. See what it looks like. Imagine that we live in a socialist society where I take up all note cards and then just pass them back out randomly. Would you be happy with your neighbor or angry with your neighbor?
Angry. I like that idea.
Jeremy likes that idea. Jeremy's neighbor does not like that idea. It's decent. It's decent. I looked at it earlier. It's not bad. Well, you can transfer it later. Okay. All right, let's go to some problems. Okay. All right, so for this one, P is the centroid. So when I see that it's the centroid, that means that my sides are cut in half. So I'm going to go ahead and mark it. This side is equal to this side. This piece is equal to this piece. This piece is equal to this piece. Okay? And then they're going to give us some different pieces of information. They say JK is 22. So JK is this whole length right here. That's 22. So what's JM? 11. What's MK? Also 11, right? Okay, we got KN is 13. What else would we know if KN is 13? What else is 13? And L would have to be 13. And OL is 18. If OL is 18, what is JO? Also 18. Okay? So, most of these we're going to already have or be able to find very easily. KM is 11. NL, already done it, 13. What's KL? It is 26. We just have to do 13 plus 13 there. JO, already marked it, it's 18. And JL, 36. Not too bad, right? The difficult part about this is recognizing what you're looking at to get your sides. Okay? Questions? All right. This one might have a little piece that's a little bit harder, I think. Okay. Z is the centroid. So if this is a centroid, that means this piece equals this piece. This piece equals this piece. This piece equals this piece. All right, now, this one's going to be a little tougher. WR, this whole thing right here, is 87. SY is 39. Now, 39, if that's 39, what else is 39? SW would also be 39 right here. And YT, this piece right here, is 48. And that is like the whole thing, not just ZT. Let me change this just a little bit because I'm going to tell you the truth, I'm not going to give you one like this. It's a little hard. Let me change something here. I'm going to change a little bit of the information. Well, I'm gonna just. Well. Okay. All right. I'm gonna have to erase it. All right. Let's pretend they give you something different. Let's say right here. I need to change this problem. ZR is 29, and instead of YT, let's get let's see. Let's do YZ equals 32. Let's change that. So we'll still do SY is 39. So this is 39, and this is 39. Let's pretend they just gave us ZR. So just this little piece right here, that's 29. And they just gave us YZ, which is 32. Okay. So WS we've already marked, it's 39. What is WY? Which is this whole length right here. 78. We just have to do 39 plus 39 to get 78. Okay. ZR I gave to you, it's 29, and YZ I gave to you, it's 32. So those were givens. That changes a little bit for the problem. All right, what is WZ going to be? What do you think, Jonas?
58.
58. How'd you get it?
I did 58. I did 87 divided by 3, and then I subtracted that from 87, which was 29.
Okay, imagine though we didn't have 87 to begin with.
Then we would do 39 to the second, and
Do we have right angles? If you don't have right angles, you can't do Pythagorean theorem. So you can't do Pythagorean theorem on these. Let's look at our note card. I said if this short piece is what? If this short piece is 6, the long piece is 12, right? So the short piece of your median, you double it to get your long piece. So pretend I didn't have 87 to begin with. You would be correct if you knew 87. But 29, if I double it, 29 times 2 gives us 58. So 29 times 2 is what I'm doing right there, and it gives us 58. All right, what do you guys think for ZT? That's going to be 16 because this time they gave us the long piece, and we want to do half of the long piece. So ZT, right here, we're doing 32 divided by 2. That gives us 16. So we'll get 16 for that. Okay, questions? Okay, this is our last one that we have to do. Altitudes and the orthocenter. So, the altitude is a segment joining a vertex to the opposite side so that it is perpendicular to that side. Okay? Altitudes can be inside or outside of a triangle. So this right here is your altitude. It's how tall that triangle is. I used the word altitude when we were doing volume formulas because I didn't want to use height. So it's sometimes used in place of height. So that is your altitude. So like this first one is very similar to the example they gave us. If I go from the vertex perpendicular to the opposite side, then that would be my altitude right there. But over here, if I go from this vertex to draw a perpendicular line, I would have to like drop a line right here on the outside of the triangle. All right, so this is an example right here where your altitude can be on the outside of the triangle. Or, if I look at this vertex, this is a right triangle, right? And so the line perpendicular to this opposite side is that side of the triangle. Does the altitude cut the side in half? Not most of the time. If it's an equilateral triangle or isosceles, it might. But otherwise, no. And most of the time, it does not. And as you can imagine, since the altitude can be on the outside of the triangle, sometimes your orthocenter is also on the outside of the triangle. We're not going to do nearly as much with the orthocenter as we are with some of the others. So we won't. It doesn't have a lot of special properties that we can apply, so you won't see a ton of these. The three altitudes of a triangle intersect at a point called the orthocenter. So for this, I just need to be able to identify the altitudes and the orthocenter. So somebody give me one of the altitudes for this triangle. Okay, B, F is definitely an altitude right here. It goes from the vertex and it's perpendicular to the other side. All right, another one. AE, very good, Josiah. That would be here, vertex, perpendicular to the other side. And what's the last one? CD. It goes from the vertex and it's perpendicular to the other side. And so on this picture, that orthocenter right there is P. Okay. There is not a lot that we'll do with these other than identify them, possibly a little Pythagorean theorem, but there's not nearly as many properties that go with it, so we won't use these quite as much. And let's add this to our note card. Okay, so on that note card, we're just going to draw us a triangle like we've been drawing. And we just want to go from a vertex, and we want to be perpendicular to the opposite side. If you want, you can use like your other note card, and you want it just to be straight in the corner there, like that. And I'll give you a right angle right there. And so we're talking about this line right here. That is called your altitude. And then if we want to draw the orthocenter, definitely go with like a not right scalene triangle here, because if you do something else, you'll end up with sometimes crazy orthocenters. So like you're going from the vertex and you want perpendicular to the other side. So if you kind of like line this up here to make a right angle, because my hand's kind of in the way there. Get this. Oh my, what did I do? There we go. So that looks like our first one that we drew. Okay, everybody good here? Alright, then we're going to go from the other vertex. This is a little harder to do, but what we want to do, line your like note card up with the edge of that triangle and just slide it till you hit the vertex right there. And draw yourself a line there. Draw in your right angle. And then the last vertex that you've got there, you're going to line your note card up so that it's right along that, slide it over until you're lined right up there at that vertex. Draw in your line. If you've done it right, they should all meet at one point right there, and that point is your ortho center. All right, check on your neighbor, see if they've got a decent looking triangle. Make sure you got your right angles drawn on that. Okay, we're not going to do the last two slides on those notes because they're kind of review, and rather than filling in that last slide, which is like a summary, we've done our note card instead. So I wish, and that last slide's just way too little. Here's what I want us to do right now. I want everybody to do the front side, okay? This is just identifying. Just identifying. We're going to do this. It should not take you a terribly long amount of time. It's just identifying. So I want you to go through and look at those. You'll need that note card, which means I need to give Maya hers. Okay. All of them kind of look the same. How can I tell I've got an in center?
You got that squeeze
Center. In, they're all in the center.
You gotta go through the whole thing.
In center is the only one that had to do with angles, right? So in center cuts the angles in half. So you're looking for one with the angles marked. Not the right angles, but the angles in the corners. A couple of these are a little bit tricky. Yeah, so you'll, I think all of them will show up more than once. Yeah. Oh, no, it cannot be two things at once. No, it cannot be two things at once. So they all have just like one answer. There we go. Okay. First one, what is it? In center. The angles are cut in half, right? That's in center. What about 2?
Ortho center.
Orthocenter. Okay.
Centroid.
Moving down. 3. Centroid. What about 4? It looks kind of similar. This is circumcenter. See the difference in those two? Both of them cut the sides in half, but for the circumcenter, you got to have perpendicular lines. For the centroid, they're not perpendicular. Or don't have to be. And are usually not. Okay? What do you guys think about this one? That one's tricky. This is a circumcenter. Because does it cut the angles in half? It looks like it, but is it marked? No, it's not marked, so you can't know that for sure. If you look at your note card, oh, I don't have my good note card anymore. I gave it to Maya. But if you look at your note card, it's that first one we had those like, actually I can show you this one. We had those like lines from here to our centroid highlighted. They're all the same. That's what you're looking at here. Okay? What is 6? It's another centroid. We can tell that because the sides are cut in half, but they're not perpendicular. Okay? If the sides are cut in half, it is either a centroid or a circumcenter. So you're looking to see if they're perpendicular for that. Okay, questions on those so far? Okay, keep going. All right, what about 7? It's the in-center. Because does that cut the sides in half? No, it does not. Like, they didn't even draw in the angle bisectors right there. All they gave you were these pieces that are the same. That's a property of our in-center. That one's tricky. I'm probably not going to give you one like that on the quiz too much. What about 8? Orthocenter. Okay. 9, in-center. Those angles are marked. It's the only one they'll have the angles marked. What about 10? Circumcenter. Okay, so what I want you to do for me tonight is number 1 through 6, which we've already done 1 through 3, right? So unless you just didn't write down what we did. And